Hope everybody's still awake after the lunch. My name is João Paulo. I work for INDT. It's the Nokia Institute of Technology in Brazil, in Recife. I've been working with Bluetooth since 2008, first with audio, and then I passed through some different profiles, and last year I started to work with Bluetooth LowEnergy at INDT.
And my name is André. I work for INDT also, working in the Bluetooth LowEnergy support on Linux. Alright, we work for INDT, which is independent and non-profit institute founded by Nokia in Brazil. We have 4 main areas of work. Which work is in the OSS and UI, which stands for Open Source Software and UI. And we have 4 sites in Brazil. We work in Recife, in the northeast of Brazil. Here's the agenda for the talk. First, we will introduce some introduction to the Bluetooth LowEnergy technology. Then we will discuss some lead profiles already supported by BlueZ. The broadcast and observer roles, which enable us to develop some interesting applications we will discuss later. And then we will discuss the current support of BlueZ and what work you have in progress now. We also have prepared some demos, which is we are going to show here later. Yeah, let's start. Okay, so what is Bluetooth LowEnergy? Bluetooth LowEnergy is a technology specifying the Bluetooth .0 specification, which was adopted in 2010. It aims to reduce power consumption on the devices. And it enables devices just like going to sell battery devices, just a watch like that, or maybe a remote control or other kind of device to communicate wirelessly for a long time, for a long duration. It says about 3 years of working devices. It provides a very fast connection establishment procedure. It's about 3 milliseconds. And it has a data rate which is 200 kilobits per second. And it's a short-range technology. It's about 50 meters. The interesting is classic Bluetooth and Bluetooth LowEnergy are in the same chip. They share the same radio. So for that reason, some operations cannot work at the same time because one part is using the radio, the other part cannot use the radio. But we have in BlueZ, we have a guy who is developing an application, doesn't need to have a lot of knowledge about if the device is LowEnergy or not. It's just transparent for the developer. All right, the market where we can find Bluetooth LowEnergy technology is in the, some of them are the consumer electronics and PC. We have remote controls running Bluetooth LowEnergy. We could have game controllers also running Bluetooth LowEnergy, 3D glasses. And we have also keyboards and mouse. We have a keyboard here to demonstrate later. In the fitness and the wellness, we have pedometers, heart rate monitors, and the watches. And in the medical, we have some false alarms, blood pressure monitors, and glucose monitors too. And in the mobile phones, we have some services like the proximity service. For example, if you forget your cell phone on top of the desk and you run away, the watch, for example, can alert you. You just forget your cell phone on the desk. And also in the sensors network and the automation services. So here is how the BLE system is layered. We have on the controller side, in the first rule there, we have the physical layer, which is the radio layer, where we have the radio, and you have the link layer, which is also implemented in the controller itself. It's implemented in the firmware of the controller. Then in the kernel side, we have the host controller interface, which is basically an interface so to the controller. You can send comments to the controller, for example, start scanning or establish a connection with this address or whatever comment you have. And then you have the LTCAP layer, which stands for a logical link control and adaptation, a protocol which provides the multiplexing and segmentation and reassembly of packages. On top of that, we have what we call the attribute protocol, which is basically a very simple protocol which uses attributes. You read and write attributes. So this is the way how you get information and you send information to the devices. And on top of that, we have the generic attribute profile, which is basically describes how you should access this data or how this data is organized. And then on top of this profile, we have the classical profiles. We have the HOG, which stands for HID over GATT. That stands for generic attribute profile. You have timing, proximity, a lot of profiles. You can also have a third-party application which basically uses the generic attribute profile to send data, to read and write attributes.
Okay. So the attribute protocol enables you to read and write attributes. And the generic attribute profile, it organizes these attributes into characteristics. So a characteristic is basically a group of attributes. You always have declaration attribute, value attribute. It's where you store the value of the whole characteristic. For example, a temperature characteristic, the temperature value will be found in the value attribute. And a configuration, which tells you what you can do with that characteristic. If you can read, write, enable notification. And also the generic attribute profile defines the procedures to read a characteristic, to write a characteristic, to enable notifications, relationships between characteristics. And then these characteristics are grouped on services. For example, we have the alert notification services that provides the service to provides alerts. And in BlueZ, we have a dBuzz API, which can be used to access the generic attribute profile directly. And it's how we enable third-party applications to be implemented. So when Andrea mentioned the third-party application profiles, it's something built on top of this profile. So another profile we have supporting BlueZ is the proximity profile, where there are two roles, a reporter and a monitor. So basically the reporter keeps reporting its distance, like it's not exactly the distance based on the signal string. And the monitor emits an alert when the distance goes over a certain threshold. So there are two ways to detect this proximity. So one is when the signal strength goes below a certain threshold, which is called path loss. That we still doesn't support that, but we support link losses, where the link is actually lost, as the name suggests. And for this profile, we have an API to set the level of the alert that will be emitted on the monitor. Similar to the proximity profile, we have the find me profile as well. But instead of emitting an alert based on the distance, the alert is emitted upon a user comment. So there are two roles, one is called locator, one is called target. So the locator sends a comment to the target to be able to find where the target is. And besides an API to start the alert level, we have support for the target role as well in BlueZ. So there is a debug signal to notify applications that a locator is trying to find them. So then the application can implement a pop-up or a sound alert or something like this. Another profile we have is the time profile. It has two services. The local time service, which is used to synchronize the local time between two devices. So you can have, for example, a watch, like the one Andrea is wearing, and a cell phone. Then you want them to have the time synchronized. And there's another profile that provides the time zone information and daylight saving time information. So that profile, one device can learn when the next, what's the actual daylight saving time status, if it's on or off, and what's the offset, and when the next daylight saving time change will happen, and what's going to be the new offset, and also what's the offset of the current time zone. And for this profile, there's no API, so just after connecting, the devices automatically synchronize the local time, and if there is the time zone information available, they synchronize the time zone information and the DST information as well. We also have support for the health thermometer profile. So this profile, the holes are the thermometer itself, which is the device measuring the temperature of someone, and the collector. And then there's an API to configure what's the interval the thermometer will read this temperature information and send it to the collector. And you can also register an application as an agent that will receive this time measurements. Another profile we have that we have worked for this last year on INDT is the GATT profile. So basically provides support for human interface devices, which talks the HID protocol. So it's HID protocol encapsulated into the GATT protocol. Also no API is needed, because after you connect, the device shows up as a new regular input device for the next server. And basically the difference between inputs over low energy and the inputs over classic Bluetooth that we call BR/DR, it's, of course, it consumes less power, but also we had faster reconnections, which was a big problem for input device over Bluetooth. And the connection procedure is a little bit different. So usually, for classic Bluetooth, the peripheral directly starts a connection with the central, which is the computer. For low energy, only the central can establish the connections. So after there is a disconnection, the way the peripheral requests a new connection is to start advertising. So it basically tells, I'm here, and then the central detects it and starts a connection with the peripheral.
So, broadcast and observer, they are roles the Bluetooth spec defines, and they are basically the broadcaster broadcasts data, and the observer listens to this data. So, what use cases? What we can think about use cases about that? We can think, for example, in a transport hub, advertising the next time the train is gonna arrive at the station. Or you can design an indoor positioning system using this kind of information. The drawback is it provides a way to transfer data with no connection establishment, but it's not there is no confidentiality, neither reliability. So you have no guarantee your data is going to be listened to by the other side. But for applications which are not so critical, for example, those ones I just talked about, the transport hub or your localization, it's just suitable. What is the current support of Bluetooth Low Energy in Linux? We already are able to discover devices using the management API. The management API is an API we have in BlueZ to user space talk to the kernel space. So it sends comments to discover devices or to pair some device. And we already have this support for discovering LE devices implemented. We have a procedure, it's called LE only, which discovery only LE devices. And you have the interleave discovery, which discovery both BR, ADR, and LE devices. Also, we have the connection management. We are able to establish connection to LE devices. We have implemented 2 procedures. The spec defines one is called a directed connection procedure, which is basically you have the address, you just send the address and send the type of the address. Because in LE you have public key and random types of addresses. You have to pass this information to the kernel so it can establish the connection. And we have the other one, which is the general connection establishment procedure, which is basically when you have a list of devices you are interested in connecting, and once one of these devices appear in the range or are in range, you establish the connection. We also already have the security manager protocol implementation, which implements the just work method and the passkey entry method. The passkey is you just type the pass so you can vary, right? So the support for Bluetooth Low Energy in kernel, the support is now enabled by default in the kernel, was enabled by default in the kernel 3.5, and we have improved the LE part in the 3.6. Before 3.5 we already had support in kernel, but it was not before we had a parameter in the Bluetooth module, so you enable the LE support once the module is loaded. We also have a generic attribute API, so we have an API a dbuzz API to read and write and discover characteristics and services. And you have some profiles already implemented. We have the proxy. Those profiles João just talked about. They are listed here. And what we are now working is we have some effort to improve the GATT API. We are working on the broadcaster and observer API, so you can develop an application to use these roles. And you have some other profiles already under development. We have the cycle speed and cadence. We have alert notification and funny alert stats, which has been mostly developed by GATT, which is around here. Just to him later. We have some. We are currently in INDT are working in some HID over GATT improvements, which are basically when the system suspends, we have to notify the keyboard. The system is going to suspend, so the keyboard can save energy. And also, the keyboard may wake up the system. We are working on supporting that. And you have also the battery service, which is basically a service which tells the battery level of the device. Right, the demos. We have the proxy key function. What is the key function? which is a device like that. You pair it with your cell phone or your host, and once you get away from your device, it's supposed to beep. So you get alert, and you forgot something. We have the timetable, but unfortunately we cannot do it right now because we just got this watch from Casio, and the firmware is not very okay. So I'm afraid it's not going to work well. I already done some tests and it's not working okay. Actually, we have other watch, but it's older, but we didn't bring it. So, and we have the keyboard from Nordic Semiconductors, which we have actually the keyboard and the mouse and a smart control, but we just brought the keyboard. Right? So let's get started.
Yeah.
First, right?
Just go out of the presentation. Can you read anything there?
Yeah.
Okay.
So
first we're going to put the key fob in advertise mode. So advertise is the way a low-energy device shows its presence to a sender button. So I'm going to hold this for a while and it's going to start beeping. Can you hear anything? Yes.
right, it's
Yeah, there you can see the key fob. So this script runs the interleaved discover, which does LE scan for a while, and then it does the yard inquire. There, the last line you can see the address 291, which is okay.
It just stopped the advertisement because it didn't.
Yeah, I'm trying to explain and do everything at the same time. So yeah, then we use simple agent here, which is yeah, it's if I put the right address here, it usually works. Okay, now we have the right address. Ta-da. Okay, so the device now is paired and connected to the host. Okay, so it's not connected.
Wait a minute. I will put in the advertise, then you discover the connect, right?
Okay, so but I think it's paired now, so I need to remove it first. Right. So let's start over here.
suppose you just start the demonstration, right? You are discovering, you just discovered the key fob. John's gonna pair with it. Then it's paired. It's stopped beeping here. So when as I go away from the keyboard, it should start beeping. I forgot my laptop.
So this is a HCI dump, which dumps HCI packets. So you can hear it beeping there.
It's just alerting me that I forgot something. And
here we got a disconnection notification.
As I get closer to the laptop, it should stop. Stop? Yeah. So this is the main use case for this kind of devices. Actually, you don't have to have a device like
connected
that.
again.
You could have the proximity alert, and your cell phone, for example. Your cell phone starts to ring or something. For the okay, the keyboard.
Actually, remove this first. Try to minimize the demo factor. Procedure for the keyboard is similar. Andre's gonna put it into advertise mode, and we're gonna discover it here. Okay, so it's the first one. In our ready keyboard.
So the keyboard, you just turn it on, and the keyboard starts advertising.
Copy it. So now it shows the passkey that has been generated through simple agent 290190. So Android types passkey in, and then the device is paired. Let me just find my key window here. Oops. Trouble with my. I think it's. Oh, what I can do. So you have caps lock on.
Oops.
So yeah, as you can see, the
Anyway, the keyboard's working, right? So.
Working software updates. So yeah, it just works as a regular keyboard. All right. So
And the watch, I'm sorry, but we cannot demonstrate the time profile because I told you guys. But what the demonstration was once the watch is paired with the host, it updates the time in the watch. I think that's all. You guys have any questions?
yeah, that's what we had to show you. So if you have any questions, feel free. Just show me. Take the microphone to you guys.
Can you show a slide of profiles, where is the temperature profiles and so on? I wonder, I wonder if these profiles are standardized by Bluetooth Alliance, or is just Linux specific for BlueZ?
It's standard by entity called Bluetooth C. which defines the whole specification and also the profile of the specifications.
And that's one of the main differences now with Bluetooth, and with these profiles being defined by a standard organization, you can have interoperability between different manufacturers. So there is already in the market support for GPSs that can communicate wirelessly, heart rate monitors that can communicate wirelessly. But before Bluetooth LowEnergy, it wasn't possible to buy a heart rate monitor from Polar, for example, and use it to connect to a watch from Garmin or something like this. But now, with Bluetooth LowEnergy, it's going to be possible. Anyone else?
Do you have an API for things like signal strength or further information about the connected devices?
For the signal strength, I don't think so. And the other question was for the reconnection devices, you said?
Well, but how do I learn which kind of keyboard is connected?
Let me, I got the question. You want to know if you have a LE keyboard or a classic Bluetooth keyboard connected? Is that the question? Actually, you have to you have how to know that, but it's users should not be worried about that. Yes, if you go digging a little bit in the code in the user space, you're going to find a property which says which kind of device is that. But the way we are designing it is the whole API is to the user, the guys who develop the application, they should not worry about that. It should work as it worked before.
Because the device API we expose the address type, right? So, but as Andrea said, it shouldn't make any difference because the same API that we use for RDR profiles, we use for low energy profiles. So, for instance, the input profile, they have the same API for both, which right now is no API because they don't need. We may add an API for this remote wake up feature we are still designing. For the device API, which the API to pair devices and stuff like that, it's exactly the same API. So the applications shouldn't worry about that. Does that answer your question? Okay. So, anyone else?
In the advertisement of a low energy device, can the device, well, it advertises its presence. It will probably advertise one of the services it has, but can it also advertise the value of characteristics in the packet, in the advertisement packet? For example, the train arrival time, will it be in the advertisement, or does it need a connection in able to?
It doesn't need a connection. It's just the information, maybe train 200 is coming. It goes inside the advertising. And then actually, it may not even be a characteristic. It's just a raw data because for that roles you can use the way you want. So.
Yeah, so that was the broadcaster and observer roles were designed for exactly what you guys.
You can put whatever you want in the payload.
Can the same device be paired with two different computers, like a Bluetooth speaker?
You mean the peripheral? You mean no?
Just to repeat the question, if the same Bluetooth peripheral can be paired with two different hosts? No, it could in theory if it had place to store two different keys, but that's not usually the case.
But it's not according to this spec. It's through the Bluetooth spec.
And they cannot be connected at the same time. Yeah.
Sucks.
For the power consumption, do Do you have any benchmarks with other protocols like ZigBee or Z-Wave where this?
Yeah, later I can send to you. I already have read some papers. Some guys in the academy is doing some kind of benchmark like that. But I don't remember the results right now. But they were a very nice papers. They had some graphics. They plot some graphics and show ZigBee and Bluetooth LowEnergy. But I don't remember right now. But I can send to you later. Actually, I may have it in my laptop, so I can take it after this. You guys have more questions? All right.
Yeah, so you can also be free to contact us both by email or find us on #BlueZ on Freenode. And if anyone wants to make questions afterwards, feel free also to come to talk with us here or anywhere in the conference. We can exchange cards and, I don't know, try some crazy ideas that you may have. I don't know. All right?
Thank you very much.
Thank you.